Hi everyone, welcome back to my channel. My name is Dr. Bisayo Tokiti, and today I'll be taking you through another series of statistics made easy. And today we'll be looking at measures of central value, or it can also be called measures of average, or it can also be called measures of central tendency. So, and what are you trying to do, or what are you trying to derive? We are just looking for a single value that will represent the entire data. And what then are average? Average are values of a distribution which is considered as the most representative for a group. Just a single value that will represent the entire group. Average. Then what are the objectives of average? One, or objective of measures of central values or average or tendency. One is to get a single value that describes the entire group of data. Then secondly, another objective is to facilitate comparison. Then what are the requisites for a good average? One, it should be easy to understand, it should be simple to compute, then it should be based on all the items in the group or category or classification. Then what are the types of average that we'll be looking at? The first type of average that we'll be looking at is called arithmetic mean. And arithmetic mean can be further divided into simple mean and weighted mean. Then we'll also look at median, we'll look at mode, we'll look at geometric mean, and we also look at harmonic mean. So the next thing we'll be looking at is each of the types of mean I listed on the board, and the first one is arithmetic mean. And what does an arithmetic mean? Like average, it is the most popular method used for representing the entire data in a single value, and there are different methods in which you can derive the arithmetic mean. The first method is called individual series, the second one is called the discrete series, and the third method is called continuous series. The continuous series is also further divided into three, where you have the direct method, where you have the shortcut method, and when you have the step deviation method. But when I get to it, I would give a deeper explanation of what it means. But I also want to show us that the individual series, because many of us will ask that why all these series, they are not the same, and each of the series attends to different questions. They solve different problem in statistical analysis, and these are the examples of each of the series we have on the board. These are so the first series we have is individual series. It means that each of the mark is attached to an individual. Let's take for example on the board number, so 1, 2, 3. This means we have 3 students, and the highest mark any student can get is 10. So for this class we have 3 students, and the first student add 5 marks, the second student add 7 marks, and the third student add 10 marks. 3 students. But there is a slight difference between the individual series and the discrete series. And what does the discrete series mean? The discrete series does not really relate with an individual. It groups the marks into groups and gives us the outcome. Let's say for example, this is 10 marks. This is 10 marks. It means 5 students add 10 over 30. We can see that the language has changed. This is saying 20. It means 20 marks. 7 students add 20 over 30. 30 is the highest mark. Then the last one says 30 students, 10 students rather, add 30. What do I mean? If I'm to ask how many students are represented in this discrete series, it means I'll be saying 5 plus 7 plus 2 plus 10. That's 12 plus 10. That's 22 students are represented here. 22 students are represented here. Unlike the individual series that relates with only one individual. Let's look at the continuous series. Like we said when we were doing frequency distribution series and like that the individual series ranges from one value to the other. It ranges from one value to the other. Let's look at what we have now. We have 0 to 5, 5 to 10, then 10 to 15. This is the lower class interval for this class. That means that we have 3 classes here: class 1, class 2, class 3. And for class 1, the lower class interval is 0. For class 1, the upper class interval is 5. For class 2, the lower class interval is 5 and the upper class interval is 10. For class 3, the lower class interval is 10 and the upper class interval is 15. But how do we read? It means that from 0 to 5, we have 5 students that add the mark from 0 to 5. So each of these students can have 5, 5 or 4, 4. 5 is not included in this class, sorry about that. We can say 4 over the total number of marks that we have, and like that. It could be 1, it could be 2, it could be 0, it could be 4. So we are saying 5 students add between 0 and 5 marks. We are saying 7 students add between 10 and 15 marks. Then we are saying 10 students add between 10 and 15 marks. This helps us to be able to group the data into smaller or more appropriate unit than larger classes. So we'll be looking at the first series, which is individual series, and usually mean is represented by bar x. And what's the formula for individual series? It is equals to mean is equals to summation x all over n. And how do we do it? It means the mean is equals to x1, each of the variables represented in that in any question that we are given. So it could be x1 plus x2 plus x3 plus x4 plus x5 plus x6 plus x7 plus x8 plus x9 plus x10, depending on the number of variables that you have. And that is why I've put n, because we are not sure of what the question will look like, and all over the total number of students. If you look at the illustration 1 says the table shows monthly allowances of 6 students in thousands. These allowances are in thousands. Find the arithmetic mean. This kind of question can only be solved through the individual series, and the formula for individual series is what? Summation bar x is equals to summation x all over n, and we have 6 students, so automatically bar x will be equals to x1 plus x2 plus x3 plus x4 then plus x5 then plus x6. I jumped a stage, and that stage is bringing all the values of x to there. 80 plus 40 plus 90 plus 30 plus 50 plus 70 all over 6, because they actually told us that the total number of students are 6. So adding 80 plus 40 will give us 120. 90 plus 30 will give us 120. 50 plus 70 will give us another 120. That's 120 in 3 places. That will give us 360. So 360 divided by 6. 6 here we have 6 and 6 is 0. So it means that the average allowance that this student, the 6th student, gets on a monthly basis is 60,000. The second one we'll be looking at is the discrete series. And the formula for a discrete series, we have said a discrete series is an event or an occurrence that happens to more than an individual. That is not an event. It could be 2, it could be 3, it could be more, it could be 20, 30, and like that. And the formula is bar x. Bar x means mean, and is equals to summation fx, frequency and maybe the marks or whatever x is represented by, then all over summation of frequency. So this illustration says the data obtained by 48 students calculate the arithmetic mean, and this is the question, and I've solved it on this board. And what does the solution look like? One, I've written out the marks as it is in the question. If you look at the question, I have 10, I have 20, I have 30, I have 40, 50 and 60, and that is the same I've represented in the solution. And the mark is represented by x. Then the number of students is always the frequency, and the number of students here says 6, 10, 18, 8, 4 and 2. Then I've written it out exactly the way it is from the question: 6, 10, 18, 8, 4 and 2. And what do we do? Since it's fx, it means we have to multiply f and x. It could be, some people might get confused because this is x and this is f. Since it's a multiplication, you can multiply the two sides. So I'm trying to multiply now. The first one says 10 times 6, that's 60. The next one says 20 times 10, that's 200. The third one says 30 times 18, 540. How did I get 540? I have a way of calculating. And what do? This is 18, this is 30. I've brought the 0 to, I'm bringing the 0 to 80. So I'll just say 180 multiplied by 3. And my answer is 520. So 3 times 0 is 0. 3 times 8 is 24, 4. Then 3 times 1 is 3. Plus the remaining 2, that's 540. So you can also develop that method of multiplying. Then the next one say 40 times 8 is 320. Then 50 times 4, 200. Then 60 times 2, 120. The total summation x, summation means addition of all the variables together. So the total of f is 48 and the total of fx is 1100 and 1440. I'm bringing it into a formula. Formula says bar x is equals to summation fx all over summation f. So bringing it to the formula, bar x is now summation fx is 1440. So 1440 all over summation f. Summation f is 48. So 1440 divided by 48 we get 30. So it means on the average, on the average data obtained, they didn't tell us what the data is, if it's allowance, if it's school fees, if it's feeding or any other allowance. So the average for this mark, for this data, is 30. The last method we'll be looking at under simple arithmetic series or mean is the continuous series. This is mean. Simple arithmetic mean. Simple arithmetic mean is the continuous series, and we said the continuous series ranges from one value to the other, and we should also know that the continuous series can be solved by using any of this method. If you use any of this method for the same question, then you would get the same result or the same answer. So the first method I will be looking at is the direct method. The second method is the shortcut method, and the third method is the step deviation method. The first one on the board is the direct method, and the direct method, the formula says bar x, which is mean, is equal to summation of f and m all over summation f. Summation of f and m all over summation f. The only new thing here is m. And what does m mean? M means midpoint. And how do we get our midpoint? Our midpoint is adding up the lower class interval and the upper class interval divided by 2. We said it in one of the videos. You can check for that video. And the illustration says the marks of students is 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, then 50 to 60. Then the frequency says 5, 10, 25, 30, 20, and 10. The total frequency, 5 plus 10 is 15. 15 plus 25, we have 40. 40 plus 30, we have 70. 70 plus 20, we have 90. 90 plus 10, we have 100. And we also said, what is m? M means midpoint. And midpoint is adding up the lower class interval plus the upper class interval divided by 2. So 0 plus 10 is 10 divided by 2, 5. 10 plus 20 is 30 divided by 2, 15. 20 plus 30 is 50 divided by 2, 25. 30 plus 40, 70 divided by 2, 35. 40 plus 50, 90 divided by 2, 45. 50 plus 60, 110 divided by 2, 55. And the next thing is to multiply f and m. F and m will be 5 times 5, 25. 10 times 15, 150. 25 times 25, 625. 30 times 35, 1050. 20 times 45, 900. 10 times 55, 550. Then adding up all this, we have 3,300. Bringing it back into the formula, summation by x is summation of fm all over summation f, and the total, the summation of summation fm on the board is 3,300 300. I've written it down 3300 divided by the frequency, which is 100, divided by 100. So if I want to divide, chalk out these zeros, so the value will be what? Our average, or a value that represents the entire data, is what? 33. Still under the continuous series, we'll be looking at the second method, and the second method is called the shortcut method. Although sometimes I call it long cut, but statistically we call it shortcut method. And what does the formula for the shortcut method says? The formula says bar x, which is mean, is equals to a plus summation fd all over summation f. A is always called assumed mean. Assumed mean. Assumed mean. Assumed mean. And what does assumed mean mean? Assumed mean means that from m, which is the midpoint, you can pick any value. That is why we say assumed mean. We can pick any value. Any value we pick, we get the same answer. We can decide to pick 5 or 15 or 25 or 35 or 45 or 55, and any of the value can be your assumed mean. And we say a plus summation fd. So d means the difference between midpoint and the assumed mean. Then the last, then we multiply frequency plus the difference, multiply by the difference between the midpoint and the assumed mean, all over summation of f, which is the frequency. Okay, looking at the question again, the mark said ranges between 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, then 50 to 60. Then this is the frequency: 5, 10, 25, 30, 20 and 10, and the total is 100. Then the midpoint, we have said the midpoint is the lower class interval plus the upper class interval divided by 2. So for the first one, it is 0 plus 10, 10 divided by 2, 5, 10 plus 20, 30 divided by 2, 25, 20 plus 30 divided by 2, 20 plus 30, 50 divided by 2, and so on. Then the next column says midpoint minus assumed mean. And like I just explained, that the assumed mean can be any of the value of the midpoint, and that is why we say assumed mean, any value. So I have decided to pick 35. I've decided to pick 35 because of my audience. Because if I pick 5, many people say, why is it that it's 5 that she picked? If I decide to pick 35, many another person will say, why is it that it is the last value we are picking? So I've decided to come in between 25 and 35. So I eventually picked 35. And what do? I've said midpoint minus assumed mean. My assumed mean is equal to 35. My assumed mean is equal to 35. So the first one will be what? 5 minus 35 minus 30. 5 minus 35 minus 30. 15 minus 35 minus 20. 25 minus 35 minus 10. 35 minus 35, 0. 45 minus 35 plus 10. Then 55 minus 35 plus 20. Then the next column says f, the frequency, should be multiplied by the difference. That is why I've said difference. The difference between midpoint and the assumed mean. That is why it is denoted by D. And multiplying the difference by the frequency now. 5 minus 30. 5 times minus 30 minus 150. 10 times minus 20 minus 200. 25 times minus 10 minus 250. 30 times 0, 0. 20 times plus 10 plus 200 plus 200. Then 10 times 20 plus 20, we have plus 200. What is our value? To get this is easy. When we have plus 200 minus 200 minus 150 minus 250, minus 200 will cancel plus 200. This is remaining 250. 250 minus 200 plus minus 250 plus 200. We have 50 deficit left. Added to this one, you have minus 200. Bringing it into the formula, we have said A plus summation FD all over summation F, which is equals to, what is our assumed mean? Like I said, our assumed mean is 35. And how did I get the assuming? Any value of our midpoint can be assumed in, but I've decided to pick 35. So 35 plus the value, which is minus 200 divided by 100. Minus 200 divided by 100 will give us minus 2. So automatically this sign changed to minus. So 35 minus 2. We have 33 as the average. The last method is step deviation method, and still using the same question, the same processes, but just a step further above, or a step above the shortcut and the direct method. And this is the same question. Mark ranges between 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, then 50 to 60. Then the frequency as usual, the midpoint. The midpoint I chose for the shortcut method is still the same. No, the assumed mean I chose for the shortcut method is still the same assumed mean I'm picking. And I said in the step the shortcut method that the assumed mean is any value of the midpoint that you pick or you select on your own, assumed. So you can decide to pick any of the values. Then the differences, like we did for the other one, the differences between midpoint and assumed mean. My assumed mean is 35. So 5 minus 35, we have minus 30. 15 minus 35 minus 20. 25 minus 35 minus 10. 35 minus 35, 0. Then 45 minus 35 plus 10. 55 minus 35 plus 20. Then the next column says midpoint minus assumed mean divided by class interval. C is represented by class interval. Some other textbook use I, but in my own case I'm using C, and C means class interval. So I'm just dividing the value I get here by the class interval. What is the class interval? The class interval is the upper class limit minus the lower class limit. The upper class limit here is 10 and the lower class limit is 0. So 10 minus 0, we have 10. 20 minus 10, we have 10. 30 minus 20, we have 10. 40 minus 20, we have 10. 50 minus 40, we have 10. 60 minus 50, we have 10. So automatically my class interval is 10. So minus 30 divided by 10 minus 3, minus 20 divided by 10 minus 2, minus 10 divided by 10 minus 1, then 0 divided by 10, 0, plus 10 divided by 10 plus 1, then plus 20 divided by 10 plus 2. Then bringing to the next column, I've decided, so that we don't get confused, if I'm representing this with D again, we'll get confused. So I've decided to represent this with X. So the formula says by S is equals to assumed mean plus summation fx all over summation f times c. So multiplying f by this now, 5 times minus 3 is minus 15. 10 times minus 2 minus 20. 25 times minus 1 minus 25. Then 30 times 0, 0. 20 times plus 1 plus 20 plus 20. Then 10 times 2 plus 20. Looking at the value, 20, they are negative and they are positive. So this 20 will struck out this 20. This is 25. 25 plus 20 minus 25 plus 20. We have a deficit of 5. Adding a deficit of 5 to minus 15, we have minus 20. So coming back to the formula says by x is equals to assumed mean plus summation fx all over summation f times c. And c is always the class interval. Some textbooks have represented it with I, but C in my own case. So by X, assumed mean is what? 35. And summation of Fx is what? Minus 20. Then all over summation F. Summation F is 100. Then multiply by class interval. Using the principle of BODMAS, would do the multiplication first. So this 0 will cancel this 0. This 0 will also cancel this 0. So I'm left with 35 minus 2, which is 33. You can see that looking at all the methods, whether you are using the direct method or the shortcut method or the step deviation method for a singular question, we still come down to the same answer. Thank you so much for watching this video. Kindly like, subscribe, and also comment in the comment section below. Thank you.